Greetings everyone, welcome to the third lecture of research methods. I would just take a few minutes to go through what we have discussed in the very last lecture. As you could recall that we have been discussing how research is done, what are research methods, and in this process we have been reviewing the very process of undertaking research from its conception all the way to execution and then documentation. And as an example, I was discussing and I shared with you, in fact, a research study done in Pakistan on solid waste management. And the last lecture, we were reviewing the very process through which the student actually undertook that research and led to execution. We ended our lecture on the topic of recycling, how households were recycling their recyclables. And in this lecture, our goal is to move forward and complete the description of the results from the previous study, and also we would like to discuss what research tools were used in that study and how other research tools could be used in your study. So I will take you to the slide that was the last slide that we reviewed, and then move forward from there. Now, you would recall that the study was about household waste generation rates, how households generate waste, and this is the domestic waste. And the questions we were addressing were if the waste generation rate has something to do with household size, income, and other determinants that we could use to study the waste generation behavior of households. Please recall that the 120 odd households that we studied or surveyed in this study came from Rawalpindi, from the cantonment areas of the Rawalpindi city. And now you are looking at the waste generation rates on your screen. And if you look at the statistics that I would like you to focus on, it's the average statistics, which is called mean here, and it's roughly 1.7 kilograms. So basically, on average, 1.7 kilograms of household waste was generated in our sample. And then the other key statistics is the standard deviation, which is roughly 2,120 grams or 2.1 kilograms of standard deviation. And this is the measure of dispersion. Again, at this stage, all you need to know is that this would be explained in the lectures that would follow. And then there's something called skewness and kurtosis, which we will discuss later. On top of it is the percentiles that give you an idea. For example, the 5% percentile is 50 grams, which shows that up until 5% of the data set, the average for that was 50 grams, and then 50% percentile or 50th percentile, the weight generated was 1,000 grams, and 50th percentile is also called median. And these are the key descriptive statistics that one uses in studying any empirical data set. So in any empirical research, these are the statistics or empirics that one deals with. And remember that we are dealing with solid waste management, and we are interested in finding out what is the average rate of waste generation per household, and then would like to know more than the average in the dispersion, and these percentiles are used accordingly. So moving forward, if you recall, we are interested in seeing how solid waste is generated and its variance as we move from low income households to mid income, and then from mid income to high income households. And what I have plotted in this slide over here is the average waste generated for each neighborhood. And if you recall, the first two are the low income, the next two are the mid income, and the last two are the high income neighborhoods. And you'd see that the average waste generated actually increases from low to mid to high income households. The lowest waste generated per household is about 800 grams, a little under a kilogram for a low income neighborhood. And the highest waste generated is almost 3 kilograms or 2.7 kilograms per day per household in a high income neighborhood. And again, you have these other statistics such as standard deviation and the number of observations, which we call here frequency, but it's an abbreviation. And then also I have provided here waste generated per capita. That is, you take the average waste generated per household and divide it by the average size of the household for that neighborhood. And what you have is here as average waste per capita or per person. And again, the numbers are presenting the same situation, that the lowest per person waste is generated for low income households, and the highest per person waste is generated for high income neighborhoods. And remember that I initially, while introducing this course, mentioned that we will spend some time looking at analytic graphics. What I presented to you in the last slide was the average waste generated per capita or per person, and I am presenting the exact same information here as a graphic. Now this is called a bar chart, and if you look at this bar chart, you could see how low-income neighborhoods generate per capita low waste per person, and the high-income neighborhoods generate more waste per person, and this is the average waste generated. And so on the x-axis we have the names of the neighborhoods, and the last one is the total or the average waste generated per capita for the entire 6 neighborhoods. And on the y-axis we have the waste generated in terms of grams, but waste generated per capita. Now a picture is always worth 1,000 words, and you could see that what you can gain from this picture right away is much more meaningful, and it communicates the underlying distribution of the waste generation trends in the data set very clearly. Now the next graphic is even more informative. What we have is on the x-axis the household size, so 0 household size, and of course there was no household in our data set with 0 household size. And then we have the household sizes 1, 2, 4, 6, all the way up to 12. And if I recall correctly, the maximum household size in our data set was 12. So the average waste generated for household of a particular size is plotted on this graph. And you would see that the blue line is the actual data, and the black line is the regression line fitted to this data, and the regression equation is plotted here. And again, we will be discussing regression in quite some detail later, but you would see from this very trend that as the household size increases, the waste generated by that household increases. So from this graph there is no confusion. We can conclude with certainty that larger households generate more waste. However, if I present to you the per capita waste generated as a function of household size, which you see in this next graph, you will see that in fact the per capita waste generated declines with the increase in household size. And these are the trends that we were looking for when we started this research. We wanted to know what is the impact of household size on waste generation rate, total waste generation, and also per capita waste generation. So you see this again blue line suggesting that as the size of the household increases, the per capita waste generation declines. And the other maroon colored line is the regression line, and the regression equation is quoted up here. And again, we will discuss this a little later in our research. So what is the next step in this research? Now we have done the descriptive analysis. We have looked at the overall global picture, which you could recall from the last lecture, which was mapping, and we showed you GIS-based maps, and then I showed you descriptive statistics of demographics and the waste. And now comes the question of doing some empirical regression modeling. But before you actually jump into that stage, you have to clearly look at the data. And during the descriptive statistics, you would find trends, and you would find some records that may be outliers. They may have measurement error, and it would be prudent to actually get rid of those data sets or those data points before you subject them to any further analysis. And in this case, I'm showing you in this slide, if you look at it, the same variable, the waste generated in grams per household per day is recorded here. And then If you look at the minimum and maximum values, you see that in some instances the waste generated was zero. It could be that the household was not available. It could be that they had zero waste. It could be one or other things. But also look at the maximum waste generated, and the maximum value is 19,000 grams or 19 kilograms. Now it's highly unlikely when your average waste generated by a household is 1.7 kilogram that you would have 19 kilogram belonging to the same data set. There may be a situation where the household has unusually high waste generation, and therefore they decided that they will dump this all in the same day. But that would affect our analysis because I would qualify this as an outlier. So I create a new variable, and the new variable is the same variable, but we remove those extreme values, the smallest values being null. We set a threshold, and let's call it an arbitrary threshold at this point, that the lowest or the minimum value we'll take is 50 grams, and the highest maximum value we'll take is less than 10 kilograms. And then you will also see that I have log transformed this variable. That is, I've taken the natural logarithm of this variable, and the minimum mean or average value 1.6 becomes 6.8, and the maximum 9.9 kilogram becomes 9.2. And the reason for this is because the data were not ideally suited for for a typical regression model. And the way I would like to explain it is, if you were to look at the histogram of the data set, you will see that the raw data is actually not depicting a normal distribution. It has very high values, peaks here at small levels, and then it goes into it thins out towards, there's a very long right tail. And by log transforming this above data, the raw data, I get the log transformation of the waste generated, and that is presented in the graph at the bottom of this. And you will see that this graph is in fact showing a much better distribution suited for a regression model. Also, if you look at this matrix graph, scatterplot matrix, I have plotted the waste generated against three variables: these households members or size of the households, number of children in the household, and the square footage of the built lot or the housing unit. Interestingly, we do not see any real relationship right away in the data set, and that's why we subjected it to a more involved analysis, the regression analysis. But the purpose of showing you these graphics now at this stage is to introduce you to the idea that the analytic graphics can actually inform you and can inform your research, so that you can actually plan better for the modeling part of your work. Lastly, the last slide presents 4 models that we estimated, where we have the explanatory variables on the left hand first column and the estimated coefficients on the for 4 different models reported and in columns E, F, G, and H. At this stage of the game, I don't think we need to discuss what these mean, but this would be the final output of a research. And this was in fact, the final output of our research here, which shows that the waste generated increases with the increase in household size. The waste generated per household also increases with the presence of children, and if the household size increases, the waste increases. And also we found some statistically significant and some statistically insignificant relationships. And so this concludes our discussion of the research on solid waste. And the purpose for showing you this research, these results, the methodology, was to expose you to how you will be using research methods and empirical analysis in your research. And now the goal for me is to introduce to you some tools that you will be needing to do research, and then formally introducing you to the definitions, and then how do you compute averages and means and modes, and how do you find correlations, and these analytic graphics, how do you execute them, and finally reaching to a stage where we actually start running econometric models. The research you have just seen on solid waste management is not possible without certain research tools. Those are primarily data, information, and also software. And I will take this time to first introduce you to such tools so that you have some idea of how research is conducted and what kind of mechanics are involved, but also what kind of tools you need for this purpose. So, for instance, here, let me begin with the software. There are two options here. You can use commercially available software, or you can use the freeware. That is the software that you can use, but you don't have to pay for it. Now, there's something that I would insist very, very strongly. That is not to use pirated software. If you cannot afford a software that you need for your research, then there are good alternatives available, which are free and easily available, equally good and powerful as any other commercially available software, so that there is no compromise, there is no step back or step down for you for not using commercially available software. Now, in conducting research, you definitely need word processors so that you can type your research, and you also need spreadsheets so that you can store your results and then graph them, plot them, and you also need some other statistical software. And I mentioned that we will be working with R, which is the freeware. When it comes to word processors and when it comes to spreadsheets, the common tendency is to use Microsoft Office, and there has been for the very long period, not many options available to use any other word processor other than Microsoft Word. But now there's a good time. I think OpenOffice is a very good freeware alternative to Microsoft Word and Microsoft Excel. And if you would like to, if you have a licensed copy, please go ahead and use it, whatever the software you have. But if you don't have a licensed copy, I insist very strongly that avoid pirated software. And the two options that I would present to you, one is called the OpenOffice, which is a complete suite of productivity tools, such as word processors and spreadsheets and PowerPoint type presentation software, and also a database, and it's all available for free. And if you were to look at your screens, I can show you. I'm presenting here the OpenOffice website. It's called openoffice.org, and it has all the spreadsheets and word processing and presentations, graphics, databases, and it's a good option. The other option that I would like to mention is the option of Google Docs. If you have a very decent internet connection, you do not really need to install any software. You can have a word processor and a spreadsheet and all of those things that you need for your research through Google Docs, and it runs on the internet, and you can actually write reports, conduct your analysis, generate PowerPoint presentations, and store them online. It's called Google Docs, and it's available from Google for free. Now, after the word processor and spreadsheets, you also need materials to conduct research. You need published research on the topics that you are interested in, and there's it becomes a very difficult task. How do you find that information? If there was a paper published, say, 10 years ago, on the very topic that you are interested in, how would you find that paper? And there are some things called research indices, and I have these here. Some of them, 3 listed here. One is called ProQuest, the other is called EconLit, and there is definitely an index in your field. And I'll take a few minutes to demonstrate these indices as to how would you find information for your research. So I will take you to the website of Ryerson University's library, and if you would see here, we have some commonly all-purpose indices listed here, and one of the interesting things that indices that I use very often is the ProQuest Research Library, and also the Web of Science. So I'll first take you to ProQuest Library, and I can do a basic search, and let's say I'm interested in um, something related with um, human development, right? Human development index, and so I can actually log into ProQuest and then type my search in the search indices, and I will type human development index, and I want to see what has been published about this human development index, and I would like to see let's say papers or information published in only 12 previous months. I would like to only look for material for which the entire text is available, and I would like to search only scholarly journals, peer-reviewed journals. This way I would avoid popular press, newspapers, and magazines. And I click search, and this is running on a server in North America. May take some time, but you will get the output very quickly. So what it's doing is that it's going through thousands and thousands of journals, and then hundreds of thousands of papers, and it is returning to me through this search material that is relevant to the search that I just conducted. And there's a paper, the first paper that you see here is called The Effects of Increased Trade and Investment on Human Development in the US and Mexican Border Communities, right? And then from these 150 documents that you see here, actually I can further fine-tune my research to get to those 20 odd papers that are truly relevant, or that may be truly relevant to my research. I in fact can ask this to see, I can actually revise this research, refine it further, and I say that apart from Human Development Index, I would like to see what has been published in South Asia, or what has been published about human development in South Asia, and not just Mexico or the United States. And I will make this open-ended now. I don't want to see the research published in the last 12 months, but I would say whenever the database started and whatever the material has been archived from the very beginning to date. And I would like to search multiple databases, but I'm restricting it to full text documents so that if I see a paper listed, I would like to read it, and I'm only recovering full text documents. And also I'm searching for scholarly journals only. So remember that we had a Human Development Index in the past, but no mention of South Asia, but now I'm restricting it to South Asia. And I have 4 papers that just showed up. The second one that I'm seeing here is the demography of South Asia from 1950s to 2000, a summary of changes and a statistical assessment. And I can actually read this paper. This is a little larger in size, 18 megs, and I would rather not try to download this. But I can also look at defense expenditure and economic growth in SAARC countries. And text plus graphics option is available here, which will show me not the PDF document, but I can also download it as a PDF document. But this text plus graphics would do. And here's the entire text of the paper. Now, the advantage of using these indices is that you are able to search through hundreds of thousands of papers and get to the very information that is relevant to your particular research. And it allows you to read about what has been done in the past, what research has been done on the past, how others have researched the same problem, and you are able to then identify gaps and niches that you would then explore in your own research. So for a literature review, where you go through the published research and mostly peer-reviewed research, not just copying material or looking for material on the internet, but going through the peer-reviewed research, you are able to see what credible authors have written about the same topic in the past. And this one was published, this paper, The Defense Expenditure and Economic Growth in the SAARC Countries, was published by the Journal of Social, Political, and Economic Studies, based in Washington. It was published in 2003, and the paper is available here. So it may not necessarily be tied to what we were looking for. We were interested in Human Development Index, but this is the purpose is to illustrate how one goes about finding research material. Now, once you have searched the published research and you have collected, say, 20, 40, or 50 papers that you need, then you can take that material and archive it, store it in your hard drive, print it so that you have a printed copy, and then you read and go through it. And once you've gone through it, then you write your own impressions, and then you record what you think the paper had presented. Your own thoughts, your own comments is what goes into your paper. So the next step then becomes how do you, once you have brought this research and have discovered it, how do you index it or record it? And before I get to that topic, I just want to show you a free option or freeware option of searching, and that's the Google Scholar option. And if, let's say, you do not have access to the ProQuest or the Econlit or Web of Knowledge, you can use Google Scholar. And if whenever you are working with Google, so I'm just going to type google.com, and I have a typo here, so enter, and you will notice here that there's this option called under More Scholar. Now Google Scholar is a very useful research tool where Google goes through the academic literature and all the websites that have an academic credential or an academic leading, so university websites or websites of think tanks and research institutes, and it searches for material there. And I'm going to search the same here, Human Development Index, and notice that I'll put quotes around Human Development Index because I would like to search for the exact phrase, and if I put quotes around it, I'm able to search for the exact phrase rather than individual words. And I'll do the same around South Asia, and click on search, and you will see here now that a lot of papers have shown up, and some of them are books, PDF documents, and the first one is Human Development in Poor Countries on the Role of Private Incomes, and just clicked on this. This is a paper published in the Journal of Economic Perspectives in the winter of 1993, and the paper. So you may not be able to get to this right away. You may need some permissions to read this journal, but there is a considerable amount of free information, working papers, so which the authors often put online, so that the individuals who do not subscribe to the journals may still be able to get the same information, but in an earlier draft rather than the very final draft that goes to the journal. So for research, for informed research, for effective research, one has to really know what has been done on the very same topic in the past, and that's why we conduct literature review, and these indices that I've just shown you are critical in archiving information and learning about what others have done. So once you have known and you've read these papers, you would like to store this information, you need to use some referencing software. The two are Reference Manager that I use, and there's a freeware called Zotero, which is an add-in, but you can actually find other freewares as well, so that you can create your own database of papers, journal articles, newspaper clippings, and then you can annotate those bibliographies by recording your comments. And the advanced software even allow you to use those databases while you're writing papers, and then you can cite references within the spreadsheet, and I will illustrate that later in a minute. So once we have done this, the next step becomes the data analysis software, and I think we will work with the software, the data analysis software in a minute. But let me just show you how a paper would be written in this case. So let me just start here. So I'm illustrating how one would actually work with the software. The documentation of research is a very important step, and there are shortcuts that you can use to streamline your work better. And the word processors that are available today can actually really make your life very easy. And I will take a few minutes to illustrate how you can actually do effective documentation using word processors. Now, as I mentioned earlier, that before you begin your research, you should have a clear understanding of how that research will be conducted and how will you create or prepare your final deliverable. And the final deliverable in our case would be a term paper if you're a student, a thesis if you are writing a thesis as a graduate student, or a doctoral dissertation, a student pursuing a doctorate. And regardless of the report or the deliverable that you're preparing, it would have some structure starting with an introduction and abstract and literature review. So what I have done here is I have spelled these things out. Right? I have a cover page, and so every document should have a cover page, and it should have a table of contents, and it should have abstract. Now notice that there's no special formatting for this, and let me show you how you can effectively use formatting that are built in, and then generate some interesting. Then you can automate some of the tasks using the facilities available in your software. The word abstract has to be a headline in our document, so I will click on headline, and now it's a headline. Right? Now I move forward, and I can type my abstract here until I reach the second headline, which is introduction of the research problem, and I will select that as a headline as well. So heading. Okay, from introduction of the research problem, we will move into literature review, and then again, this is a headline. Now, or a heading, and from there we move to methodology, and of course there will be many pages between this and the next section. Within methodology, first let me select methodology. So again, a headline or a heading, and the next is data collection. But data collection may be part of the methodology, so I will create a subheading, and I'll call it heading 2. And then from there, research methods. Let me just take it here. So heading 2 here, research methods. Then the next step would be results from analytics, and that could be a new heading as well, heading 1. And followed with another major section of the paper, which is the discussion of your results, and I'm applying a heading there as well. Lastly, you move into conclusions and apply a heading there as well. There you go. And last, then the housekeeping part of your report, the acknowledgements and references and appendices. And I'm applying a heading here. You can also do the highlighting and bolding of the. You can make this text bold and make it look like a heading by yourself, but that would not be able to automate a lot of the research related things that you have to do in a report, such as creating a table of contents. Now, if you move with, if you look at the section on table of contents here, once you have written the report, now you have to generate a table of contents, a list of tables, a list of figures, and this all goes with the documentation part of your report. Often people actually retype the entire table of contents and search for the page numbers and whatnot, but there is an automated way of doing this, and I'll illustrate how you can do this. You can in fact go into the, you can use one of these options, and I'm illustrating, I'm clicking on table of contents, and I'm selecting this one option, and there you go. Here it is, a complete table of contents generated from you. Now imagine if there were 40, 50, 60 headings in your document. Imagine that the document was 400 or 300 pages long. Imagine you had to type those references, the headings, and find the page numbers, and if you type another section, that page number changes, and then you have to redo the table of contents. This, by coding our document here, when I coded this, instead of making the text bold, I in fact applied a code, a built-in code in the software that made it recognize it as a heading, and a heading of certain type. Now, if you look at it here under methodology, you will see that the subsections under methodology, that is data collection, which I highlighted as heading 2, and research methods to be used as a second layer heading. you see them as indented and differentiated from the main headings, which was heading 1. And this is one way of being high on productivity, that you write your report, your term paper, and then quickly you can generate a table of contents. Now, this is all fine and good, but then there's another thing which you often have to do, that is to have some tables and graphs and charts in your report. Now, let me illustrate how you can do that part of your research more effectively as well. Now, when you're presenting results from analytics, and I will do something here, I will just go on the next page, and here I will insert a table, and then I create a caption, and then show you how that process could also be automated. Now, let me pick this table here, and I select a table, and I paste it in my document. Now remember that the captions for tables are always on the top of the table, and the captions for figures are always at the bottom of the figure. And instead of typing something like table 1 and then typing the text here, I would do something different. I will say I will generate a coded table caption. So I would say insert, and then from here there's an option to insert a caption, and I have this conveniently placed in my top bar here. And I say insert caption, and I select table, and I say OK, and now the table 1 is selected, and I can type the caption right here. Good. Then I can actually do something else as well. Now I would like to insert another table, and this time around I will repeat the same process, that I will put my table here, insert the table here, and instead of typing the caption myself, I will let the software insert the caption. So let me pick another table, and let's say this table. We just arbitrarily putting it here, and the purpose is to illustrate why automation is better than doing it yourself. And I will insert another caption, and notice now that I'm not labeling or numbering my captions. These captions are being generated automatically by the software. So I say table, insert the caption, and notice that it already is identifying it as table 2, and I type the table caption here. This is the caption. Okay, good. Now you have 2 tables, and you have 2 captions. In the process of writing this report, you realize that in fact table 1 should be table 2 and table 2 should be table 1. Right? So what we can do is we just select this, Control C or Control cut it, and I'm going to cut this and paste table 1 under table 2. So if I make it a little bigger, you can see here that table 1 is now under table 2. This is table 1, this is table 2. Now if you had done this by yourself, and if you had not coded it, then you would have to take the time and effort to renumber the tables. But if I were to just click on print preview and make it bigger, you will notice that table 1, which was table 2, which was labeled or numbered as table 2, is now table 1, and table 2 is automatically coded as table 2. Right? And this automation would save you headaches of renumbering your tables, renumbering your figures, because as the text moves back and forth, sections are cut from one place to another. You review, you edit, and while you're editing, you're moving tables, you're moving graphs from one section to another. If you keep them joined or coupled with your captions, and the captions are coded the way and inserted the way I have inserted them, you will not have to worry about their numbering. They would automatically be numbered in the text. 2 more things that are very beneficial from this very technology. One is the way to cross-reference. Now let me show you this. Let's say I type this here, that in the following table. Instead of following table, I say in table 1. Now I have two options. I say in table 1 we see that, and then blah blah blah. But here I have typed table 1. What if the same had happened, that I call this table 1, and after editing this table became table 11 or table 12? To avoid worries about how text is moving back and forth, instead of typing table 1, what I can do is I can cross references, right? So I select cross referencing, and I delete this, and I say cross reference. So here's the cross reference, and I've conveniently placed in my top ribbon here, and I say I would like to cross reference a table. So I select table, and I say instead of the entire caption, I only would like to cross reference the label and number, and I select the table that I would like to cross reference. In this case it's table 1, and I say insert, close, and table 1 has been inserted, right? So far so good. But what if the same thing happened? Now table 1 is table 1, but what if I cut it and paste it here? So table 1 should be now table 2, right? So if this table 1 becomes table 2, what happens here? Just click on print preview and see the magic. It automatically updates it. Now the table 1 became table 2, but not only that it became table 2, the text reference also updated automatically. And this is a technique for you to save hours and hours of time, especially for those of you who will be working on your dissertations, which are very large documents, and it becomes really cumbersome to take care of all these referencing. Now remember that we created a table of contents. Every table of contents should also have a list of tables and a list of figures. So let me generate a list of tables. I will click here and go for table of contents. Instead, insert table of figures, and I will insert a table of figures, and I will select a style called formal, and I'm clicking it here. Okay. And look, the list of tables has been automatically generated for us, and the page, it has already been assigned the correct page numbers. And if we were to move our tables in our document, this table of contents would be updated automatically. Now these are some tricks, some shortcuts to be productive, to avoid the hassle of numbering again and again, and when you have very large documents, this is a big headache, and therefore one becomes too much concerned about the mechanics and the renumbering, rather than focusing on writing and documenting, which is the main purpose of your research. So I hope that these some tricks have been a little bit helpful. They will allow you to be more productive. They will allow you to be focused on writing and thinking, rather than focused on typing up table of contents and taking care of referencing. The other tool that I would like you to consider for a while, for the next few minutes, is the spreadsheet. Now, as I mentioned, that I will be running this course in the statistical analysis in R, which is which is a software designed for statistical analysis. But it certainly does not. You still need an Excel type spreadsheet for work. And let me explain why. You will generate tons of data. You will generate tons of tables, and a good way of archiving that information, a good way of keeping your tables somewhere so that you can actually go back and forth is to use a spreadsheet. So you will not be doing your actual statistical analysis, but you will be using a spreadsheet to store your results. And also spreadsheets allow you to do some quick thinking, some quick number crunching, which may not be very involved, but it's equally insightful. In fact, I do not use calculators anymore. I in fact rely on spreadsheets and use them as a spreadsheet. So for instance, if I were to let's create a table, a very small table. I'll start by saying sales. Let's say we have sales data on something, and we have also the month here, and I would say January and then from January to December. So I could actually type February, March, and so on and so forth. But spreadsheets are very intelligent. If I just see this dot here on the right side, if I click on this dot and then I stretch this cells down, and if I want to go to December and I leave it there and I say fill series, it has filled the entire series for me, right? So spreadsheets are very useful in this way. There are thousands of tricks built into these spreadsheets, and they have tremendous amount of these value-added shortcuts built for you. And sales, for instance, I would just dummy up some data. Let's say it's a shoe store and you sold 250 pairs and 2,500 pairs in January and 2,200 pairs in February, and in March you sold 4,500 pairs of shoes and 3,400 pairs in April, and so on and so forth. Now, once you have created this spreadsheet, you can actually find the difference between the sales in 2 months is by creating this simple function here. I would say subtract the sales in February from the sales in January, and I click here, and I actually see here that my sales were 300 fewer pairs of shoes were sold in February than they were in March. The advantage of using a spreadsheet is that if I want to do this for the rest of my data set, I'll simply click here and stretch it, and now I have the monthly sales differences for the rest of my data set. If you were to be doing this with a calculator by your hands, you had to type this again and again, but once you have the data, a spreadsheet, you enter the formula once and it then copies over and allows you to see the differences, and you don't have to retype it again and again. So these are the two the tricks, and it is difficult to explain the advantages of a spreadsheet in an hour or even 5 hours. I would encourage you to read a book on how you can do analytics in spreadsheets and to save yourself some time and be more productive. Lastly, I would like to show you how we can use some referencing software, which is the indexing software. Let's say you have a database in a reference manager, and I'm illustrating reference manager here. So in the literature review, I would write that, for instance, the waste management technology or the waste management practices in the developing countries are still not prudent. But I would like to now source this material. I've made a comment, I've written a statement that the waste management practices in the developing countries are not prudent. But there's a reference that goes with it. Somebody else actually wrote a paper, perhaps, or a book, or some other intellectual property, something else is available, and I would like to quote it. Now I can actually, the way to quote it is to say this was written by, let's say, famous Pakistani economist Mahbub ul-Haq. So you would say Haq, 1995, for instance, right? Or you can actually use a reference manager, and then you have to type this reference at the very end. I use a reference manager to store my references. So I click here and I say insert citation, and you would notice that all of this is already built into my word processor. And I would say I'm looking for a paper by, okay, so I have a paper by another author. So working out of poverty, a conceptual framework, and I would like to cite this paper. So I say insert. Now this paper is inserted in the document. It says Huck 2004. And what is interesting is if I scroll to the end of this document, under references, this paper has already been, so you could see that I did not type this text because this reference was available in my database and I knew this paper. So when I cited it through my word processor and the reference manager, it created this reference it put this reference in my document. Now, if you were to go through some academic papers, you would notice that an academic paper would have 10, 20, 40, 50, and if it's a review of previous research, hundreds of papers. And this allows you to, this reference manager and the techniques that I've shown you allow you to actually not only track the papers and the material you have read and you have written your comments, and then you can use those reference managers to record your comments and notes, but also be very productive in the writing stage. When you're writing your papers, you will be referencing others' research again and again, and these papers would come up. Now, to illustrate this one more time, I would go back and I would say not only that I would like to reference this paper, but I would like to reference another paper. So I remember seeing two papers here. Let's say another author who wrote a paper called Basic MEMAP Poverty Profile of Pakistan, and I would like to quote this. So I insert this paper, and see what happened here. So now notice that these two papers are already here, and I'm just going to highlight it, make it a little bigger so that you could see. So both authors and both these papers have been referenced. The Huck paper is here, and the other second paper, which has multiple authors here. And if you're writing papers, you would notice that each and every publication require you to follow a certain style in referencing or citing other people's work. And these software that I'm mentioning, reference managers and the like, they allow you to actually adopt, conform your referencing or citations according to the style. The most commonly used academic styles are the APA style and the MLA style in the academic world. And so these softwares actually take care of the formatting of the references and citations. And again, you can see here that now the second paper has already been inserted, and notice that the second paper has been inserted on top of the paper that I had earlier. The reason being, the author of the second paper, his last name starts with A, and the author of the first papers, that person's name starts with an H, and the references lists are always in alphabetical order unless the journal specifies it to be any different. So in conclusion, you saw how various tools, research productivity tools, are required to do efficient research, to do quality research. It's not that they are absolutely necessary, that you may not be able to do research without them. So that's certainly not the case. What I'm suggesting is that you can do a good job and you can focus on research and the intellectual endeavor rather than being bogged down by concerns related to formatting and should this comma be here, or should there be a period after the year of publication. These concerns actually take a lot of time when you're writing research. And if there are tools out there that can make your life easy, I would strongly suggest that you make good use of such tools. So the tools that I mentioned were word processing tools and the tools related to spreadsheets, so that you can do some number crunching, and also how would one use references or reference managers to cite references or cite works of previously completed. I hope that this introduction to tools for research is helpful, and encourage you to explore other such tools, mostly freeware, that may be available for your. Good luck with research.